Okay, class, let's try to work out some procedures to balance what I would call hard chemical equations. So there's two real methods to do this. One is the more straightforward trial and error method. And the second one, for what are considered hard chemical equations, would be using methods of algebra. So we're going to go over both types of methodologies. The trial and error, which probably most of you have encountered in your schooling, and then a couple of the more difficult ones. I got these last two equations online, which they boasted as being very, very hard and very difficult to balance. Well, we're going to try to attempt to balance those using some of the methods that you'll learn here. Let's go ahead and try to balance the first of our four chemical equations. We have here C6H12O6 plus oxygen, O2, goes to CO2 and water. Okay, this type of reaction is called a combustion reaction. So reactions can be of different types, and anytime you have a CHO type of molecule reacting with oxygen, a CHO in this case is a sugar, reacting with oxygen, and that yields CO2 and water, that's a combustion reaction. For you biochemists out there, this is called glucose. And we want to balance this equation. So the way to balance this chemical equation is to understand the law of conservation of mass, which states that the molecular weight of the reactants, so here we have two reactants, glucose and oxygen, must equal to the molecular weight of the products, and that equals to CO2 and water are the products of this combustion reaction. So we have to hold our atoms accountable. No atom or no mass can be created, and no matter or no mass or atoms can be destroyed. So there has to be accountability. So let's have our accountability between the reactant atoms and our product atoms. So first we have carbon, hydrogen, and oxygen in our reactant side. And in our product side, we have carbon, hydrogen, and oxygen. So notice we have no more atoms, no less atoms. Whatever's in the reactant are the same atoms that are in the product side. So for carbon, we have 6 here in the reactant side, and product side we have 1. For hydrogen, we have 12. Here in the product side, we have 2 coming from water. Now our oxygens are going to be 6 oxygen atoms from the glucose, 2 from molecular or diatomic oxygen. That's going to be 8. And for oxygen in the product side, we have 2 from carbon dioxide and 1 from water. So that's going to be 3 oxygens. Okay, just as a side note, this is a nonmetal, this is a nonmetal, this is a nonmetal, so we expect this to be a covalent bond. So carbon will have a bond with hydrogen, which will in turn have bonds with oxygen. So this is not an ionic interaction, this is a covalent bond. In fact, everything here are covalent bonds. Okay, the sharing of electrons in the form of a bond. All right, let's get back to balancing these equations. What I usually like to do is to balance the loner last. So the loner here is oxygen. That's all sitting by itself. So you can balance everything else, and whatever oxygen is left over, you can just put it here. Nothing else gets affected because there's no other covalent bond with oxygen. It's not covalently bound to any carbons or hydrogen. So usually you'd like to balance your loner element or loner molecule last. All right. So let's do that. Go for the simplest first. The simplest first would be the carbons. So if I were to make a guideline, maybe balance loner last. Now you're going to have to find out what the loner is. And then I would usually like to balance my hydrogens and oxygens last. Okay, this is a general rule of thumb, but it's usually not set in stone. Okay, in this case, my oxygen represents my loner, so usually I'm going to balance that last. So go for the easiest first. This is the trial and error method in this combustion reaction. So the easiest first would be to balance the carbons. So we have 6 carbons on the reactant side. I'll put 6 carbons on the product side. And that implies we now have 6 carbons. How many oxygens do we have? 6 times 2 is 12. 12 plus 1 is 13. Okay, so we've gone from 3 oxygens to 13 oxygens. Now, the second easiest thing to balance would be my hydrogens. Now, how would I balance my hydrogens? I have 12 on the reactant side. I have 2 on the product side. I can put a 6 in here, and that gives me 12 hydrogens on the product side, 6 times 2, with 12 hydrogens on my reactant side. All right. So how does that change my oxygen? Now I have, in terms of oxygen, 6 times 2 is 12, plus 6 is 18. Okay, so now I have 18. Now how do I get 18 here on the reactant side to balance my oxygens? Okay, that's the question. I can't put 9. 9 times 2 is 18 because I have that 6 over there. Okay, so what do I need to do so that 6 oxygens plus 2 oxygens plus something else should yield 18? Okay, so this is where the trial and error comes in. If you do a little trial and error, there's nothing wrong with plugging in numbers, but you'll find that if you put a 6 here, that means you'll have 6 times 2 is 12 atoms of oxygen plus your 6 atoms of oxygen coming from glucose, and that will give you your 18. Okay, so the balanced chemical equation here is going to be C6H12O6 plus 6O2 goes to 6CO2 plus 6H2O. So here in equation number 2, we have C4H10 plus O2 goes to CO2 and water. So you can see here, just as with equation 1, we produce carbon dioxide and water. And we have a hydrocarbon here. This is called a hydrocarbon. And you can guess or infer what type of reaction this is. You would be right if you called it a combustion reaction. Any type of hydrocarbon, just like in equation 1, any type of hydrocarbon, or in the previous equation, sugar, quote unquote, burns an oxygen yielding CO2 and water, that's a combustion reaction. So we can do the exact same thing as before and hold our atoms between the reactants and the products. And you will see here that carbon has 4 in the reactant side. What do I need to do to get it to 4 on the product side? Let me just fill these out here. Okay. So if I put 4 carbons on my reactant side on carbon dioxide, now I have 4 elements of carbon, and now my oxygens have changed from 8 plus 1, which would be now 9. Now, let us balance the hydrogens. Remember, like we said before, this is the loner molecule, so we want to balance that last. If you see a loner molecule, you tend to want to balance it last. Hydrogen is 10 here. If I put a 5 here, that gives me 10 hydrogens, but my oxygens have changed. Now they become 8. 4 times 2 is 8, plus 5 is 13. Okay. Now the problem is, how do I get to 13 from 2 using oxygen? And the key is you can use a fraction. Okay, you can use 13 halves. When you do 13 halves times 2, the 2's cancel and you're left with 13. Okay. Now generally speaking, you don't want to have fractions as your coefficient. You want to have just nice whole numbers. So what we do is we multiply across this chemical equation by 2 to get rid of this 2, to essentially get rid of the fraction. So when we multiply by 2 across both sides of the chemical equation, so I'm going to multiply 2 across this equation, I'm going to get 2C4H10 plus 13 oxygens goes to, or yields 8CO2 plus 10 H2O. You can always double check your work, making sure that you are atom balanced, and when you're atom balanced, that automatically infers that you are mass balanced. So I can take the molecular weight of this hydrocarbon, by the way, this is called butane. I can take the molecular weight of butane multiplied by 2, added to the molecular weight of oxygen multiplied by 13. That sum must equal to the molecular weight of CO2 multiplied by 8 plus the molecular weight of water multiplied by 10. That's mass balanced, but atom balanced would mean that you're automatically mass balanced. So the main point here is, what I want to emphasize is this thing, okay? Get rid of the fraction, and generally fractions are to be avoided in a balanced chemical equations. So looking at equation 3 and how to balance it, you can try trial and error. In fact, you can go ahead and do trial and error. I think you'll find that you're going to be pretty exasperated and flummoxed. And so there is another method that is a little bit superior to trial and error, and that is generally what's known as the algebraic method. And this is really used to balance hard chemical equations. So in our first one, we used trial and error. The second example, we used trial and error, but we had a fraction. So just be aware that fractions are going to pop up their ugly head. Okay, fractions. And now this method, it's a little bit more complicated. So let me go through this step by step using what we'll call the algebraic method. Okay. The first thing I want to do is I'm going to label each reactant, and I'm going to label each product and give it a variable. So I'm going to call copper A, I'm going to call HNO3B, I'm going to call COCuNO32, copper nitrate. I'm going to call that C, I'm going to call this nitrogen monoxide D, and I'm going to call water E. So copper is A, HNO3, nitric oxide, is B, CuNO3, 2, copper nitrate, is C, NO is D, and water is E. All right. So now I have here A as my copper. So I have copper, and that's going to be A. I have H. Okay. That's going to be B. I have N. That's also going to be B. All right. And then I have O. And what is O going to be? That is actually going to be 3B. I have covered everything in my reactant side. So whatever's in my reactant side must equal to whatever is in my product side. So now let's go to copper again. I have A. Where is copper in my product side? It's here. So what is copper here? It is also C. What about hydrogen? Hydrogen was B on my reactant side. What is it on my product side? It's going to have to equal to E, but how many hydrogens do I have? I have 2 hydrogens, so it's actually going to equal to 2E, okay? 2E. Nitrogen, I have 1 nitrogen B on my reactant side. How many do I have on my product side? Okay, this is a little tricky. I have 2N, so I have 2C. Okay, because copper nitrate is C. I have 2 nitrogens in C. And I have 1 nitrogen in D. So 2C plus D is going to equal B for balancing the nitrogens. Okay, what about oxygens? I have 3B in HNO3, And how many do I have of oxygens in my product side? This is tricky again. I have 3 times 2 oxygen in C, so that's 6C. I have 1 oxygen in D, so plus D. And I have 1 oxygen in E, so that's plus E. So now I have 4 equations that I could use to solve. Now, if you look carefully, I have A is going to equal to C. My copper is going to equal to whatever is in C. So here I can put an easy number for A, and whatever number I put in for A, it will automatically equal C. So usually what people do, they're not going to let A equal like 1/2 or 2/3 or some fraction. They will let A equal to the simplest number, and that simplest number is 1. So if you let A equal 1, be simple now when you encounter this. That means what? It means C is equal to 1. Okay, so I let A equal 1, the simplest case scenario, and that means C is also going to equal to 1. Now I have to figure out how to balance these equations. Now, with these equations are filled with variables A, B, C, and D. I already got A and C. I let A equal 1, and I let C equal 1 by virtue of this equality. So the first thing I would do is probably plug stuff in. So I'll plug in C here. So B is equal to 2 times 1. C is equal to 1 plus D. So now this implies B is equal to 2 plus D. I would also put that C and plug it in here. And I would get 3B is equal to 6 times 1 plus D plus E. So 3B is equal to 6 plus D plus E. Now what is E here? E is nothing more than B over 2. So I will put B over 2 there. And then I will multiply both sides of the equation by 2. So I'll have 6B is equal to 12 plus 2D plus B. So when I do that math, I'm going to get 5B is equal to 2D plus 12. So further manipulation, I can take this B and plug it in here. So when I do that, I'm going to get 5 times 2 plus D, which is B, is going to equal to 2D plus 12. And now I think I should be able to get D now. So 10 plus 5D is equal to 2D plus 12. And now 5D minus 2D is 3D. 12 minus 10 is going to be 2. And now we have D is equal to 2/3. So now D is going to equal to 2/3. Right, so I got A, I got C, I just solved for D, just substituting in. This is simultaneous equations. Now we are left with B and E. Well, B is 2 times E, okay? B is also equal to 2C plus D. We just solved for D here, so let us use this equation here, and let's put this here so we're not so confusing to ourselves. So here B is equal to 2C. We already figured out what C is. C is 1. Plus D. We already figured out what D is. That's 2/3. So B is equal to 2 plus 2/3. Okay. So 2 plus 2/3 is going to be, if we do those fractions in our head, 6 plus 2, it's going to be 8/3. Okay, so that is what B is going to equal to. So B now is now 8/3. And the only thing that's left is E. So E is nothing more than B over 2, or B is equal to 2 times E. All right, so using this equation here, okay, if B is equal to 2E, this implies E is equal to B over 2. All right, we already figured out what B is. It's 8/3. So this implies that E is going to equal to 8/3 times 1/2, which is going to be 8/6, which is the same thing as 4/3. So that is what E is going to equal to. So now we have E at 4/3. All right. So there we have it. We have A, B, C, D, and E. So let's put them in. Okay. So A is 1. So let's go move it up here. A is 1. That's copper nitrate. B is 8/3. So we have 8/3 HNO3. C is 1. D is 2/3. So there's D. And then E is 4/3. Okay. So A, B, C, D, and E represent coefficients. So after solving for A, B, C, D, and E, we have our balanced chemical equations. Remember, we do not like to have fractions as our coefficients, so we multiply everything by 3. So we have 3Cu plus 8HNO3, plus 3 here is 3CuNO32 plus 2NO plus 4H2O. So that should represent your balanced chemical equation, okay, after all of that algebra. So let's just do our check. Copper here on our reactant side, and copper in our product side. Copper here is 3. Copper here is 3. Let's take a look at our next element, hydrogen. Hydrogen is 8 hydrogens. Here we have 4 times 2 is 8 hydrogens. Let's take a look at nitrogens. We have 8 nitrogens. Here we have 2 nitrogens times 3 is 6. 6 plus 2 nitrogens is 8. Okay, so let me tell you that again. 2 nitrogens times 3 is 6. 6 plus these 2 nitrogens gives you 8. And then the oxygens, 8 times 3 oxygens is 24. Okay, let's look at this one carefully. 3 oxygens times 2 is 6. 6 times 3 is 18. It's 18 oxygens here. Once again, 3 times 2 is 6. 6 times 3 is 18. Plus 2 oxygens plus 4 oxygens. So that is 24. So here is your balanced chemical equation. All right. So here is another quote-unquote complex chemical equation to attempt to balance. And again, if you can do the trial and error and get away with it, that's fine. But you can always use the algebraic method. So here, instead of putting A, B, C, D, and E on the top or on the bottom, I'm just going to actually make them coefficients. A, B, C, D, and E. That gives you a better idea. That the A is going to represent a coefficient for S. B is going to represent the coefficient for HNO3. So now we have sulfur, we have hydrogen, we have nitrogen, and we have oxygen. Sulfur is A in our reactant side. What is sulfur in our product side? Sulfur is C. So A equals C. What is hydrogen in our reactant side? B. What is hydrogen in our product side? 2C plus 2E. 2C plus 2E. What is nitrogen in our reactant side? B. What is nitrogen in our product side? D. Remember, whatever's in our product must equal whatever's in our reactant. Whatever's in our reactant must equal to whatever's in our product. What is oxygen in our reactant side? Okay, be careful now, it's 3B. 3B. And what is oxygen in our product side? Okay, be careful now. It's 4C plus 2D plus E. Okay, it's going to be 4C plus 2D plus E for oxygen on the product side. 4C plus 2D plus E. Okay? So like before, we have to solve for A, B, C, D, and E. Now, here, let's let A equal 1. Let's let A equal to the simplest number, not a fraction. So if you let A equal to 1, then this implies C is going to equal to 1. All right? So we want to get A, B, C, D, and E. We know A is equal to 1, and that C is equal to 1. Okay? I actually forced that relationship because A is equal to C. I can make A 10 or 200 or 1/2, though 1/2 would never be good as a coefficient. But no, I'm going to make A equal to 1. And by this first relationship, C will equal to 1. Okay? So now I just, in my mind, I'm thinking about plugging stuff in. Okay, plugging stuff in to try to get some relationship going. So I'm going to plug in C here. All right, and when I do that, I have B is equal to 2 times 1 plus 2E. So I have B is equal to 2 plus 2E. Okay, that may be good to know. I have the B and E variable. I can also plug in C here, and when I do that, I have 3B is equal to 4 times 1 plus 2D plus E, so 3B is equal to 4 plus 2D plus E. Okay. Does that help me? I guess so. I also have this relationship. I have B is equal to D, so I guess I can plug in B or D into this equation. So I'll have 3B is equal to 4 plus 2, instead of D, I'll put B here, plus 2B plus E. And now I can move the B to the other side, so 3B minus 2B is B equals to 4 plus E. Okay? So this is good. I feel like we're getting somewhere because I can solve for this and this. B equals 2 plus 2E here. B equals 4 plus E here. So now if I equate equation A with equation B, I'll have B is equal to 2 plus 2E. B is equal to 4 plus E, so I'll set them equal to one another. 2 plus 2E equals 4 plus E. And have 2E minus E is equal to E. 4 minus 2 is going to equal to 2. Yes, I got E is equal to 2. Okay, so I solved one of them. So now that I know E is equal to 2, let me just plug stuff back in here. All right, if E is equal to 2, that means B is equal to 2 plus 2E. Well, E is equal to 2, right? So B is equal to 2 plus 4. I got B is equal to 6. All right, so now I have B equal to 6 here. And now whatever B equals, D equals by this relationship. So I have D equals to 6. So coming back here, I have A, B, C, D, and E to substitute. A, B, C, D, and E. So let's rewrite this now and see if it's balanced. Okay, going back up here, all right, I have A is equal to 1, so that's going to be S. B is equal to 6, so that's going to be 6HNO3. C is equal to 1, so that's going to be 1H2SO4. D is equal to 6, so that's going to be 6NO2. E is equal to 2, that's going to be 2H2O. And this should be my balanced chemical equation. Now I'm going to take a deep breath and hope that I am right. Okay, so here are my reactants. Here are my products. I have S, H, N, and O on my reactant side. I have S, H, N, and O on my product side. So here I have S is 1 reactant side, S is 1 on product side. H, I have 6 H's, so that's 6. H's here on my product side, I have 2 plus 4, so I'm good with 6. Nitrogens, I have 6 nitrogens here. Here I have 6 nitrogens. Anything else? No. Oxygens, I have 6 times 3. Here that's 18. Here on the product side I have 4 plus 12. 6 times 2 is 12. Plus 2, the 2 oxygens, plus 2. So that is 18. So I have now balanced my equation. Okay. So this is if you're good at algebra, this is probably the way to go, simple algebra, to solve what are considered very hard or complicated equations. So if trial and error fails you, you may have to go to the algebraic method and solve a system of simultaneous equations. But always try trial and error. Also be aware of fractions and realize we can't have fractions as coefficients in our balanced chemical equation. Okay, thank you.